So let's be honest. Everyone on this page, on this page, is this the first page? Hopefully I turned in the right workbook and get photocopied because that might be possible. I gave you the wrong one. All right. Do you remember the whole thing in Algebra 1? We're going to talk about the F word, factoring. Remember this? So you might have found that there were people who sat around you who were really good at it, and you're sitting there going, this is a different language. Raise your hand if you thought factoring was a different language. It's okay, Ken. It's okay. Be honest. I did too. Okay? So I want to make sure that we feel comfortable with that factoring and how we can get around it if we're not bad or if we're not good with it. Okay? Especially because being that we're going to be doing tests and quizzes together as a class, I'm not a resource, by the way, when that happens, but I bet you something that I say would stick with one or two of you to get really good at it. Now, who feels that they're really good at factoring? Yeah, that's okay too. Okay? Now, there's all different, I think one of the big problems with factoring is you might have heard it done one way by a teacher who might have done something called the diamond method. You have the square method, there's the box method, there's the dream method, there's the partial method, and there's actually one that's called the Cherry Creek method because it was developed in Cherry Creek, as in a high school called Cherry Creek, New Jersey. They developed it, so they coined it. It wasn't Cherry Creek High School, but it's kind of cool. It's called Cherry Creek. But if you weren't able to do factoring, because factoring came in all types of different things. Now, as long as the variable, the letter in there, is the same throughout, you should be fine. Okay? If you come across like a problem like number 6, or like, it's only number 6 on my page right there because I don't have the whole thing up. 6 has multiple variables. Agree? You have X and Y. Okay, now, I need your phones out, please. I need you to go to the App Store. You still following me in this adventure? Does this make sense? And then I need you to add Desmos, D-E-S-M-O-S. Okay? Now, this is going to become a pretty valuable tool for you. What would be great is if you could find it on your computer as well. But you're going to load Desmos, and it's green. Yeah.
Is it Desmos graphic calculator or Desmos scientific calculator?
Oh, yeah. I got to look. It's the one that looks like.
Does it have the squiggles on it?
Yeah, it's green with squiggles.
Okay, so that's the graphic one.
Yeah, it looks like that one when you load it.
Okay. There's like 2 of them.
Oh, yeah. Yeah, it's not the top one. It's the one with the, that's
Yeah, the squiggles, yeah.
squiggles. Everyone find it? No, that's not it. Everyone find it? So I want you to become familiar with Desmos. And yes, this will work on the graphic calculator as well. But the next thing is, let me ask you this. Who in here has used Desmos before in math? A couple people? And that's great. We are going to become good at it. And this is why you're going to become good at it. How many of you would really walk around day to day, walking around with a TI-84 graphic calculator? I have a degree in math, I won't. But you know what I know each will walk around with each day? Your phone. Agree? That makes sense? So as long as you can start comprehending what Desmos is doing, you're going to do wonderful with it. So x squared minus 49, some of you might be able to identify that right away, saying, hey, it's x plus 7, x minus 7, that's the answer. That's how you go. It's the difference of 2 squares, and then the rest of the students are looking at it and going, what? And that's okay. But let's kind of cheat the system a little bit. And what I'm going to do is I'm going to pull up Desmos here. And it's just desmos.com. Go to the graphing calculator. Did you all find this chain link looking thing? Is that the one that you loaded? So we're gonna use technology to reinforce what we know about graphing, or what we know about factoring. Factoring is one of those things that we taught you in Algebra 1, And some of you might have an okay teacher, and then some of you might have somebody other than me. Okay? So let's take a look. That first problem was x squared minus 49. Do you agree with me? So what we're going to do is we're going to cheat the system. We're going to say, hey, y equals. And we're going to say that x squared minus 49. And I'm going to change this to a little bit darker mode for you so you can see it a little better. All right. The nice thing with Desmos is I can hover at the 2x intercepts. And those x-intercepts happen to be the solutions to the problem. Meaning, I'm just trying, I know that some of you know all of this language very well, but I want to just reinforce and try and bring us up to a pretty good level. -7, if I take -7 and I plug it in for x, the answer becomes 0. Okay? If I plug +7 in for x into our original equation, we'd also get 0. Okay? And you're like, okay, we know this stuff. I know you know this stuff, but I just want to make sure you feel comfortable because we've been on summer mode. Let's face it. Y'all are on vacations and hanging out with friends, and the last thing you were thinking about was math, probably. Okay? So those are the two answers. But the nice thing is, because those are my two answers, and you know the solutions because the y value is 0. Okay? So now what we're going to go back to is we're going to come out here and we're going to say, okay, if I did x equals 7 and x equals -7, those are the two solutions that work. I'm going to inflate this a little bit because I know I can. I'm going to focus just on this problem there. So I'm going to do x equals 7 and x equals -7. Does everyone feel comfortable where that just came from? That terminology. Is any of this foreign, or does it seem to be okay? So we got those two answers because those were the two locations that when we graphed this and we had to add y equals to make it work on Desmos, this is where it crossed the x-axis. And so what you can do when you factor it is then you just kind of reverse engineer it. You're like, okay, if I subtract 7 from both sides here, that gives me x minus 7. And if I add 7 to both sides here, that gives me x plus 7. And this is the factored version of what is above. Okay? And that works really nice if your x-intercepts happen to fall on whole numbers for answers, in which ours did on Desmos. It fell at +7 and it fell at -7. So we factored just now x squared minus 49 by utilizing the technology, the tools that we have of today to get the solution. And the nice thing is, I'm pretty sure that if you haven't mastered factoring, I probably won't be able to teach you factoring as well. I know you probably saw factoring in Algebra 1, you might have seen it in geometry a little bit, and you probably saw it in Algebra 2, and you're like, dude, I just had 3 years of this stuff, and I still don't remember the whole thing. Agree? Some of you are like, I have this, I know this, I got you. I just wanted to play around with little technology to look at that. So would you do me a favor? Would you try using Desmos on number 2 and then figure out what that would factor to? Now, some of you might be able to factor it and say, because I'm really good at factoring, especially when in front of x squared is a 1, I can do that very well. But just tell me what you maybe came upon where it crossed the x-axis. And remember, make it y equals x squared plus 4x minus 32. Does anyone want me to tell me where it crosses the x-axis? 2 locations. No? Yes? How much? -8 and +4. Do we agree with that? Does that feel comfortable? Okay, so let me ask you this. What would this factor to by me moving the -8 over and me moving the positive 4 over. What does it factor down to?
X plus 8 and X plus 8 and X minus 4. Right. So basically what you would have done here is you would have said, I'm going to add 8 to both sides, and I'm going to subtract 4 from both sides, and this comes up with the solution. And this is nice.
And now you're saying, sir, you had me in algebra 1, you didn't show us this? Big jerk. Has anyone seen factoring done this way? I mean, factoring, yeah, it's a pivotal part of algebra. But now that we are beyond algebra, we are in business calc, we can say, you know what? Yeah, I know what it goes and does, and I theoretically know what it should happen to the problem, but I'm not quite sure the routine I had to do to factor. And I will tell you this, majority of everything that you've learned in elementary school all the way up till today, you don't really recall it. Yes, you probably had spelling quizzes and tests, and so you learned how to spell somewhat. But now, it's your older life. How many of you, when you type something up and you see that, I'm not sure which writing program you might type stuff up on your computer, but you're typing up a report, do you really worry about spelling as you're going through, or do you allow the spell check, the technology to help you? I'll be honest, I use the spell check. I mean, I'll type something up, and while I'm typing it, if I know I typed it incorrectly, I'll probably make the correction, but I'll utilize the technology. Now, there are a lot of teachers out there that'll say technology is going to destroy the human brain and the thought process. And I say no to that. Because, think about, I was in high school, I graduated high school in 1989. A long time ago, yes? Perhaps some of your parents graduated right around then as well. Okay, maybe after, maybe in the 90s, maybe earlier, I don't know. So, everything that I was able to learn in school was the same thing that they had been teaching in school. Like, I could have went back to 1950s math classes, and I probably could have seen the exact same thing, taught the exact same way as I would have learned it when I was in high school. And that got me to this point right now. And I'm pretty happy about who I am. I'm happy with what I do. I'm happy to think that I have gotten to the point in life that I have no problem saying, you know what, I was wrong and I'm sorry. But I also feel that because you guys now have technology, I mean, you ever taken a test where you're like on the first, second, third, fourth problem, and it's just drawing a blank? Like, you kind of know what it's asking, but you're like, oh, and that's normal. But now you're at a point where it's like, well, let's not get hung up on the stuff that would have been taught anywhere from 1 to 10 years ago. Let's move past that and utilize the technology to allow our brain to say, okay, this is what it got to. I knew it was supposed to get, in this type of situation. I know the answer is probably right. Now I can think further. So what I feel when you guys get to my age, which is a long time from now, I can't imagine what you guys will be able to develop and think through, because the basics, yeah, you were exposed to them, you might not have mastered them. That makes you normal. Okay? Can anyone tell me what you did last March in your math class? Any of the days. What about last May in your math class? Can you tell me one lesson that you have? Wow. Yeah, I feel the same way. I don't even know what I talked about yesterday. Okay, but we're here in the now, but we have the technology to allow us to, okay, we have this, let's get this, let's move beyond this to think at even a higher level. Whereas my generation, I was stuck at x squared. Well, we can now use that old thought and jump further into like futuristic thinking, which is kind of cool, I feel.
And I might be a geek on thinking this stuff, but I'm pretty happy about where we are with technology. And I've listened, I'll go, trust me, I've been in all those meetings in the past couple weeks, and you get these teachers, they are just mad at the world because, oh, kids are using Chat GPT. And it's like, dude, it's pretty cool that they're able to communicate at this situation, at this juncture. Yeah, I think, I mean, when I go to a doctor, I want the doctor to check me out, but you know what? I'm like the rest of people out there. I'm exposed to all of these different drug commercials. Oh, I might have to take that drug because I need that for the rest of my life. I'm actually the guy that I don't like to take any forever drugs. That's just me. I'm not saying that forever drugs are bad. I mean, there's certainly things that people take because things in their body stop working. Like me, my thyroid at age 40, so 14 years ago, my thyroid, this little tiny gland that's about the size of a piece of pencil lead, that's about a ½ inch long, that rests right here. My thyroid at age 40 stopped working. How did I know it stopped working? I went to the doctor. He did a blood test and said, hey, your thyroid's not working. I didn't know that little tiny gland that's right here stopped working. So they put me on ground up cow or pig thyroid medication. I kid you not, that's where thyroid medication comes from. Now, drug companies have developed, hey, we got a new synthetic that's much better. It's like, well, I kind of like eating beef, so they keep slaughtering the cows. I'm going to have thyroid medication. And you know how much that thyroid medication would cost me to take? Nothing. It's free. Okay, there's so much of it. But I found a way to supersede taking thyroid medication. I started taking potassium iodide, 2 minerals, potassium, K, iodide, I, join together a nice covalent bond, make potassium iodide, which does thyroid need? Needs iodine. Started taking that, go to the doctor after I took that, and he said, oh my gosh, your thyroid's results are unbelievable. I need to cut your thyroid medication in half. Okay. Kept taking the potassium iodide, cut my thing down. Go see him the next year. Oh my gosh, your thyroid's doing unbelievable. I'm going to cut it in half again. So I'm at about 1/16 of what I had taken now for my thyroid. Just goofy information about stirrup. Because I did research, I used technology to figure out what naturally occurring minerals, and I choose to take the tablet of potassium iodide as that, because the other way I could get enough potassium iodide in my system is I could eat kale twice a day, every day. Any kale fans in here? Yeah. So I ain't that guy. I ain't eating kale twice a day, every day. Nice to know that there is a plant out there that I could get and I could eat and it could be good for my body. But I'm sorry, that whole kale thing. Yeah, if it's mixed in with a salad, I'll cover it with ranch to disguise the flavor. Yeah.
You can also put it in the smoothie.
In the smoothie, I have actually done that,
Yeah.
and you can't taste it that way too. I like that. So those are some things. Now, hey, do me a favor. Would you try number 3, doing the same thing on Desmos? And just see if you can decipher what the answer is going to be. Now, it's going to come out the decimals. And then you get to the decimals, it's like, sir, it doesn't work anymore. Okay, well, let's see if we can figure it out. But plug in y equals 4x squared minus 13x plus 3 on Desmos to see if you can figure out where it crosses the x-axis. And I might or might not know where at the top of my head where it crosses. So 0.125. So x equals 0.125 and x equals 3.
Yeah, 0.2.
Oh, 0.25. I'm sorry. 0.25. Thank you. So 0.25 and 3. So do you feel comfortable with my answer?
Yeah.
So now you're at the point going, well, I can get this right side. X equals 3 as a binomial is x minus 3. Agree with the information I just gave you? that make sense? So I know the right side of this is going to be x minus 3 because I would subtract 3 from both sides. I can get that. But now I have this x equals 0.25. Okay. We're going to have to use the other F word in math. Does anyone know what the fraction 0.25 is the same as? 1/4. Okay? 1 divided by 4 is 0.25. Okay? Now, if you were not sure about that, you try and calculate, you go 1 divided by 4, get 0.25. You could utilize the technology saying, you know, hey Siri. Okay. 0.25 is the same as what fraction? Well, technology will give it back to you, which is pretty cool. Okay, so there are some decimals that you have can be written as fractions. Fractions that can be written as decimals are called rational numbers. Okay, so a rational number is something that could be written as a fraction. It's also a whole number. There are some decimals, like pi, okay, 3.14159 keeps going forever, never repeats, no pattern to it. You can't write pi as a fraction. Now, some people say, oh, it's 22/7. That's approximately what it is, but that's not exactly what it is. So sometimes if this here, this 0.25, becomes a decimal that goes out like a long, long way, and you get to the point on decimals, the decimal's like, I gave you 10 decimals, this is your subtle hint that this is an irrational number. If it's an irrational number, it can't be written as a fraction, which means that I can't make it a binomial. But being that we discovered that 0.25 is the same thing as 1/4, that means that I can go ahead and get this. So let's change this. I'm going to multiply both sides by 4. The reason I'm doing that is I'm getting rid of that. So now I realize that 4x is equal to 1. So 4x equals to 1. I subtract 1 from both sides so that I know that this factored is 4x minus 1 and x minus 3. They're both going to be the same. But again, we're utilizing the technology to allow us to go deeper into a concept. Okay? Now, when people say, when am I going to have to use this in life? Well, you probably won't have this in everyday life. But what I'm trying to show you is there are definitely things that you will come across in life that you're going to ask technology to clarify something. Agree? I know I do. Heck, hey, go to my maps. I want to go here. And then I hit go, and I follow the directions on my phone. Turn right at the next intersection. Turn left. Make a U-turn. Right? We do that. We've all done that. I mean, if we ever get like all the satellites to fall out of the sky, we might be in big trouble because no one will know how to read a map any longer. I mean, back when earlier you go on road trips, like we go over to the store and we get, okay, we're gonna go from here to the state of Washington. Okay, so let's get a Colorado map, and we'll probably go up to Wyoming. Let's get a Wyoming map, and from Wyoming we're gonna go through Idaho. Let's get an Idaho map, and then let's get a Washington map. And we're gonna look at the maps and say, okay, you want to take this color road because the little ones are smaller roads where you're going to have stop signs and stuff. Let's take the interstates. And you can get there. That's how we used to do it. Now, you can say, hey, I want to go to the state of Washington, plug in the address in the state of Washington you want to go to, and artificial intelligence is going to say, hey, this is the fastest route. It's like, oh, there's toll roads. And now you can say, I don't want any toll roads because I don't like to pay to drive. I'm already paying for my gas. So it's going to say, okay, it's going to recalculate a different route that doesn't have toll roads. But you could get there pretty easily with that piece of technology that you carry with you each and every day. So people are like, oh, cell phones are going to go away. No, I think cell phones are just going to continue to improve. I have no idea what cell phones will look like. I mean, figure this. When I first started teaching, cell phones weren't available at that point. Okay? We had car phones, and then there was this huge brick of a phone that you could call
somebody with this big brick of a phone. It didn't fit in your pocket nicely because it was honestly like, I mean, it probably weighed 3 pounds and it was clunky and it had a battery life of like 40 seconds. I mean, it's crazy. But that's how technology has allowed us to progress. Now, just for fun, would you try to do number 6 on decimals? And you might get kind of a goofy one. Now, here's the key. We can't go y equals. Why can't we go y equals on this one? Why can't we do y equals on number 6? Yeah, you already got y's on the right side, right? So then you're kind of at a little crossroads. You're like, okay, 10x squared, y to the 4th, minus 25, x squared, y to the 5th. So see what decimals does for you. I don't know what it will do. I knew what it did last year, but you know what? Technology improved. You got some smart people out there doing stuff. Yeah, photomath will do it for you, but I'm not looking for photomath. I just want to utilize technology because, you know, once you're done with all of your schooling, you're going to forget you had photomath and you're looking at your apps going, what's this? Does it show anything on a graph? Or is it just kind of sitting there like, you know, staring back at you going, yeah, what do you got there, buddy? I don't know what it shows. Does it show anything good? Huh? Nothing. All right, so that means that our tricks of the trade now stopped working. Okay. So, a few things that we need to do. We get to this type of problem, we have to think a little bit deeper. We have to bring back in a little bit of our prior knowledge. So we're going to take a look at this, and I'm going to say, well, I know that 10 is 2 times 5. Do you agree with that? And I know that x to the 3rd is the same thing as saying x times x times x. Do you agree with that? And I know that y to the 4th is y, 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 y. These are all being multiplied together. So that's this first part. Oops, I don't want that there. But then our second part is, I know I have a minus sign, and I know that 25 is the same thing as 5 times 5. Agree with that? And x squared is x times x. And y to the 5th is how many y's? 5 of them. Okay, so now we're going to see if we can possibly start going through and factoring this with kind of going old school. And it always drove me nuts when I would see teachers going, don't teach it this way, you're not teaching it. It's like, what do you mean? Teaching kids to say, okay, let's compare the red to the purple. Well, I have a 5 and I have a 5. Do you agree that those are the same 5 numerically on both? And I have an x, and I have an x, I have another x, and I have another x, but I can't go to the third x because I don't have 3 x's on the red. And then I can go to the y's, and I have a y, and 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 a y. And so what I highlighted between my two problems is what? What did I have the same on both? I had a 5, that's the same. How many x's did I have the same between the two? 3 or 2? 2. What's x times x? X squared. How many y's did I have the same between the two? 4. So y multiplied together is y to the 4th. Now I'm going to do parentheses. Okay? In the red, what do I have left that was not highlighted in the red? 2x. I had a minus sign that we have to remember that. What did I not highlight in the purple? And 5y. Now it's factored. Okay, so sometimes we might get to a limit until technology catches up to that type of problem that we might have to kind of go the old school way. Go the elementary school way. There's times that I'll do that type of problem where like a whole bunch of math teachers get together. You want to know what you call a bunch of math teachers getting together? Boring. And then they're all sitting there trying to show, oh, I can do this in my head so fast. enjoy. Okay? I don't care. I'm here to teach kids. I'm not here to sit there and compare what my math knowledge is over the math knowledge of the person sitting across from me. So I will literally do this problem this exact same way. And they're like, why are you doing that way? Well, I'm doing it that way because I'm trying to get into the mind of a student to say, you know, I'm looking at the student that looks at that problem saying, you know what, I'm going to skip that one. So now I'm going to be able to try and convey a message saying at least the student that would skip that one, I would hope at some point in my class would say, you know what, I'm going to try it. I'm not going to leave it blank any longer. Have any of you ever left a question blank on a test? You're like, dude, no way. I have. It's like, forget about this. But just some thought processes of how you could start going a little bit further into, you know, some of the things and characteristics of math. You know, the nice thing is Desmos is going to work very nicely for you, but are there problems that can't get factored? What do you think? That's something that might happen? Yeah. There might be, I'm going to jump to, this is not in your notebook, so I don't see any of these off the top of my head that are going to work. I'm going to go here, go here. Would you try and plug this into Desmos? Would you plug that into Desmos? And tell me where that might cross the x-axis. I just made it up off the top of my head. I have no idea. It should, I can tell you, it should cross the x-axis at least one time, but it might not cross up to 5 times. It could. I got real lucky to cross 5 times the x-axis, but it might only cross once. Crosses 3 times? Cool. Okay, can you give me one location where you can see it cross? X equals negative. Okay, my gut tells me this is more than likely an irrational number. An irrational number can't be written as what? A fraction. Okay, was there another location you saw? 0. What? I think that's also irrational. Where's another location? I would think that's another irrational. So what it comes down to is this type of problem that I just made up won't factor. It doesn't mean it doesn't have solutions. A solution is where it crosses the x-axis. Okay? Can I tickle your brains a little bit? Have you all, I bet you've seen this in a math class before. Probably in Algebra 2. You ever see a parabola that looks like this? Opens up. Seen it before? So the unique thing about this situation is this parabola does not cross the x-axis. Is that safe for us to say? Remember, this is the x-axis here, right? So it does not cross the x-axis. Got a big question mark. So what this means is my solution, what I'd have to plug into it, becomes something called a not real number. Now, mathematicians from the past, I kid you not, this is like geeking out a little history for you, okay? Cross-curricular for you. Math at the olden days was used to show higher or smarter people than others. It's like, oh, this person, you know, come over here, Pythagoras. Hi, I got a triangle. Archimedes, come here. No, I'm just trying to make gold out of lead. Hey, patient, come here. No. Okay? These were used. The solutions to this problem, a long time ago, they named our number systems. You started learning a number system when you were in kindergarten. Remember that class? You all remember your kindergarten teacher, don't you? I had Mrs. Cropen. Okay? We all loved our kindergarten teacher, didn't we? He was a nice person. Then you'd walk in, and he had nice carpets on the floor, and he had chairs that were tiny. But they seemed big to you because we were tiny in kindergarten. Okay? Kind of funny. But there was the start of the number system called the counting numbers. And above the board or somewhere in the classroom, you might have had 1, and there might have been a single apple. And then you might have had 2, and there might have been 2 bananas. You might have had 3, and there might have been 3 cars. Remember that fun number line usually sits above the board? And then as you progress through, you learn about nothingness, the whole concept of zero. Does anyone want to know where the concept of zero came from? Anyone want to know what country it came from? What do you think?
Oh, no, I want to know.
You want to know?
Yeah.
Anyone have an idea? Give it a shot. Came from the ancient Mayans. Came from South and Central America. The whole concept of zero. Because on the other side of the ocean, they were counted by Roman numerals. I'm glad we aren't doing Roman numerals these days. So, dude, what's your number? It's I, BBI, X, BBI, X, BBI, X, BBI, D. Huh? Hang on, let me try and get that in my phone. They didn't know that. They didn't have that confirmation. You know it's time to go? We had this much fun. Hey, friends, let's do this. Would you give me, try a couple of those problems? We won't work on them tomorrow, but we'll work more on them. We will work more on that worksheet on Monday. It's not due Monday, but give it a try. Take a look at Desmos because we have a real life math thing tomorrow. Sound like a deal?